Newton, and we've really taken advantage of Newton this year, so I apologize. He led a module. I apologize to you, Newton, not to you. Led a module at the field school, and we actually did a duplicate demonstration trial for him this year. So without further ado, thanks, Newton.
Thank you. I hope I'll be loud enough that I won't need this. Okay, most of us know that the soil beneath our feet there is actually teeming with life. A lot of organisms, a whole different world down there. It looks very inert from up here, but it's actually a world full of organisms, both macro and microorganisms. Now, they do a lot of wonderful things for us. I know some of them are pathogens, but the vast majority of them do wonderful work for us. And today, we'll just show you a couple of things that they do, and one of them has to do with nitrogen fixation by Rhizobia, and the other one has to do with phosphorus acquisition by Mycorrhizae. So we have these demonstration plots here on nitrogen fixation, and over there something on Mycorrhizae. We'll come to that a little bit later. And so, because these microorganisms are so small, we can't see them with our naked eye, we usually know about their activities from whatever structures maybe they leave behind. So in the case of Rhizobia, as they interact with legumes, they form these nodules, and these are the factories of nitrogen fixation. That's where the nitrogen gets fixed. So it's a symbiotic relationship in the sense that the Rhizobia supply the plants with nitrogen, whereas the plant supplies the Rhizobia with carbon. So the photosynthesis, that carbon that the plant fixes, gets transferred to the Rhizobia. So it's a symbiotic relationship. The plant gets nitrogen, the Rhizobia get carbon. Now, it's a very expensive relationship from the plant point of view because that carbon is not cheap. The plant can use that carbon for its own growth and for its own physiology. But because it needs that nitrogen, then it gives some of that carbon to the Rhizobia. Now, the point I'm getting at here is that if you have a soil, for example, that already has a lot of nitrogen, either residual nitrogen or you actually apply nitrogen fertilizer, then what you are signaling to the plant is, well, why should I invest in this Rhizobium business or in these nodules when in fact I have nitrogen here already with me? So because it's an expensive process, if you supply the plant with nitrogen fertilizer, or if you seed that legume in a soil that already has quite a bit of nitrogen fertilizer, then that symbiosis won't be as effective. So the plant will just take that free nitrogen, of course free to eat, not to you, and not bother about inviting the Rhizobium in to fix nitrogen for the plant. Now, how many people use inoculants here? Okay. Granular or peat? Granular peat, 50-50? Okay, the ones that like granular, why? Easier to work with? Cheaper? No, not necessarily, just easier. How about peat, the one that use peat? The price is good? Okay, okay, yeah. So what I'm hoping to demonstrate to you here is that those two formulations of Rhizobia, of inoculants, actually form different patterns of nodules. And for one of them, the granular inoculant, is actually applied to the soil, whereas the peat inoculant is applied to the seed. Now, Rhizobia are not very mobile in the soil. Now, they will multiply, but they won't move with water and everything, not as much, okay? So when you apply or when you inoculate your legume seed and then plant that seed, most of the Rhizobia is just around where you planted that seed. And so when the plant germinates, it's those first roots, the primary root and a few of the laterals that emerge first, those are the ones that will get nodulated first because that's where the rhizobia is. So with pit inoculation, then you get what we call crown nodulation. So most of the nodules are around the crown. Now I'll see if I can, I dug up a few areas, but they have dried up already. So I'll see if I can dig some fresh plants here. So this is, okay, I'll just show you the treatments. So this is lentil, uninoculated here, low nitrogen. And it's the same thing that in that next replicate. And the other two, they are for peas. So it's the same treatment. So uninoculated, low nitrogen, that raw, for both lentil and peas. And here we have pit inoculant, both for lentil and for peas at the back there. And over here we have granular inoculant, same thing. So before you start to assess nodulation, one of the things you have to look at is just looking at the plants, because we're talking about nitrogen here. So nitrogen deficient plants will look yellowish, whereas plants well supplied with nitrogen will look greenish. So one of the things you look at is just look at the plants. Is there any difference between that treatment here and this treatment in terms of plant color? Or is there any difference between this one and that one there? Now, I don't see much of a difference, and I suspected two things. Either the background nitrogen here is very high already, or that the plants are still young. And so usually, if you see the peas at the back there, they're just beginning to flower. From flowering to pod filling stage, that's when they will need a lot of nitrogen, and that's when differences will show between a plant that's not getting enough nitrogen and one that does, or that is getting enough nitrogen. So in this particular case, it's a combination of both. I'm told the background nitrogen here is 60 pounds of N, which is quite a bit actually. But secondly, if we come back maybe at pod filling stage, we might see color differences here, but we're not seeing that color difference yet. But we might still see, well, as I said, I was here before, so I know there are nodules here. So I'll dig up a few plants.
Is there any nodules on this stuff here too? Like, is there any?
There would be, and as I say, I've been here before. So even here, there could be nodules, and actually there are nodules, and that's because the soil has indigenous rhizobia, or native rhizobia. So the populations are not the same, but they'll have native rhizobia in there. So you might see nodules. Now, the thing about native rhizobia is you don't know whether they are good fixers of nitrogen or not. Some of them could, others could not. But what you want is that you want your nodules to be formed by that inoculant that you put in, because you know that the company selected that strain because they know it's a good nitrogen fixer. So if you just see nodules and they are formed by indigenous rhizobia, you don't know whether you're actually getting good fixation or not. Okay? So yeah, so let me start here then and see. And so when you're digging the plants for nodules, of course, you don't just pull them out like that. You'll be stripping the nodules. So you actually dig around the plants, dig deep down and get the root at the bottom. Okay? Okay, I see one nodule here, but not a whole lot many. So there's hardly anything there.
I got nodules. You wouldn't have done that yesterday. It's nice and wet today. These are demo plots, guys, so come on over and rip them out. Yeah.
Okay, so uninoculated, hardly any nodule. Yeah, there are some there, but not necessarily around the crown, not as many around the crown as I would have liked. So apart from looking at how many nodules you have, you also have to look at the size of the nodules, how big they are. And also, what's their color? Now, when you just dig up the plant, you can actually tell. You don't have to. Now, I've got some water here. Sometimes, if the soil is very muddy, you might need to spray your plant so that you see the nodules very well. Oops. But in this case, we don't have to. I can see them. So apart from the distribution of the nodules, you have to look at the nodule size and then nodule color. And now these ones here, they look pretty pinkish to me. So you should have pink. If you crush a nodule, it should look pink inside. It should have some pink juice inside. So that's a sign of a nodule that's fixing nitrogen very well. Oops, sorry. So dig up some granulars here. And actually the peas might be better examples. I dug up a few, I put them on the side there. You can look at the peas later.
Do you figure it'll take longer for the granular inoculant to get the nodule started?
Yeah, I was going to come to that point. So the difference between crown nodulation and which is what I said about seed inoculation. So most of the nodules are formed on the crown. So and because the nodules, I mean the inoculant is in the vicinity of the plant, those nodules on the crown tend to form first. Okay? Whereas with granular inoculants, the inoculant is in the soil. You are applying the inoculant to the soil. And so it will take a while before the roots, or some of the roots, some will reach that inoculant very quickly, but some will take some time to reach that inoculant. And that's why, so quite a few of the nodules under granular inoculant will be on lateral roots instead of on the ground. Now, so the difference then is those crown nodules form first, and so they'll start fixing nitrogen first, but then they will also die earlier, okay? So whereas these other guys, they'll form late and start fixing nitrogen a bit later, but they'll also keep fixing the nitrogen well into the life of the plant. So you get a trade-off both ways. So a good combination is where you have good both crown nodulation and lateral root nodulation. Okay?
But when you've got a land that's been in rotation with pulses for several years, you do kind of build up a natural...
That's true, but I think it's always better to inoculate anyway.
You still inoculate, but what I'm saying is you get some that will come on naturally.
That's right, yeah. And because those are in the soil, they will take form on the lateral nodules. On the lateral roots, that's true, yeah. Okay, now on the other side here, what we wanted to show you, is there anybody who grows dry beans here? No dry bean growers? A little bit. Do you inoculate or you apply nitrogen? Inoculate? Good, yeah. Because quite a few guys in the Lethbridge area, in the irrigation zone, they don't bother about inoculating dry beans because they say that beans are known to be inefficient nitrogen fixers, and so they don't even bother. Instead, they just apply nitrogen. So what we wanted to show you here is treatments where we have applied a lot of nitrogen. We have applied nitrogen fertilizer. So what that does is, first of all, it will discourage nodulation. But even if you have nodulation, there won't be much nitrogen fixation in those nodules because, as I said before, it's an expensive process for the plant, and so the plant invests in that system if it is in a nitrogen deficient soil. But if you give it enough nitrogen, it won't bother to fix nitrogen. So that's why, again, it's not very clear here, but I mean, it wouldn't be clear here anyway because it's all high nitrogen content. But what we're supposed to show is that there will be very little nodulation in these plants here because of the high nitrogen. But there are actually some here already, but not as much as where you are inoculating in a low nitrogen soil. Although, as I said, this soil though, 60N is not really low N, that's quite a bit. And that brings me to what we call starter nitrogen. Some people say, should you apply starter nitrogen? Now, if you're applying that phosphate fertilizer like 1121, that's got enough nitrogen there already. So you don't need to apply another nitrogen just for the rhizobia, to help the rhizobia. So in most cases, there's no need to apply any more nitrogen fertilizer. Just rely on that rhizobium, because otherwise you are just replacing that biological process with a chemical process if you apply fertilizer.
Newton, I had a question for you.
Yeah.
If we're applying a granular inoculant and we're putting it seed placed, and you're also putting it seed placed with that 1152, is there any toxicity issues with the fertilizer itself, or is it rate dependent, or is it completely safe?
I know there are toxicity issues. If remember when granular started coming up, people didn't have that third tank to apply for application of granular. So some people thought, well, can't I use the granular? Can I just put it in the fertilizer tank? Now there will be a lot of toxicity when you are mixing.
But even if it's in
granular,
a separate tank, it would still be mixed together.
That's right, but not as much. So the soil has a way of conditioning things. So there will be issues, but not as much as actually using one tank for both fertilizer and granular inoculant.
Did you catch what I meant, though? I think what I'm saying is that if we may still have a separate tank,
okay, yeah.
then you've got 1152 in a separate tank, but they're going through the same seed run. So it'll go through the same hoses, and it'll be with the seed. I know that we usually put the fertilizer down in levels that are not going to damage the seedling itself, but I was just curious if you know if there's any potential for damaging the inoculant.
Yeah, I'm not aware of any study to that effect, but I think as long as it's good for the seed, it shouldn't be too bad for the rhizobia as well. But yeah, no, I haven't come across any results to that effect.
Speaking of the starter fertilizer costs, how much is actually needed?
Well, people say up to 30 nitrogen is not too bad. Once you start getting to 60, then that's not starter anymore. Now you're just replacing the rhizobia. But up to 30 shouldn't be too bad.
That's pounds of the actual nitrogen.
That's right, yeah. Okay, we'll come to the mycorrhiza here. And we're fortunate we have a representative here from Premier Tech, which is a company that manufactures a mycorrhiza product called Mike Pro, and his name is Mark. I'll let him speak about mycorrhiza. I already showed him these plots here, so he knows what's going on.
Well, thanks, Newton. I won't take a lot of time here, but like Newton mentioned, we manufacture inoculants at Premier Tech. Premier Tech is a Canadian privately owned company. We've been working in horticulture and agriculture for, horticulture for well over 10-15 years on the inoculant side. But in terms of agriculture, we're relatively recent, about 5 years. And our main focus is the mycorrhizae. So as Newton mentioned in his introduction, we have good fungi and we have bad fungi. We try and spray to get rid of all the pathogenic fungi, but there's actually fungi in the field that are there to help your plant uptake nutrients. And the mycorrhizae is a beneficial fungus that associates with root systems of both pulses and cereals. So we do have some demo plots here on cereals as well. But the idea is to build a stronger root system and increase your surface area for nutrient and water absorption from the soil. As probably a lot of you know, we invest money in putting fertilizer down at seeding, and we know that the plant itself is somewhat limited in what it can uptake from the soil. So having these beneficial bacteria and fungi are there to help basically optimize your nutrient uptake. And what we see is that obviously translates to healthier crops, and that translates to higher yields. So we do see in a lot of the pulses better increased yield. And in the cereals we also see increased yield, but one of the aspects that we're starting to dig into a little bit more is the quality aspect. So if you can imagine that you're uptaking more nutrients from the soil, those will end up in your seed and will help your plant resist stresses and also increase that grain quality. So there are different types of inoculants to try and make things easy for the growers to use. So there are different formulations and different ways to apply it, but the idea is that you want to get that mycorrhizae down just as the same concept as your inoculants for nitrogen fixing. You want to get it down close to the seed, on the seed or in the furrow, so that as soon as that seed germinates, it starts forming that symbiosis or that network to improve nutrient uptake for the plant. So in a nutshell, that's the idea behind using these kind of inoculants to improve your plant production, is to not replace fertilizer or chemicals, but it's used as a tool to basically maximize whatever you guys are already investing in and putting into the soil for your crops.
I just dug up some plants here from Mike Pro and Nan there. I think they're in this order. In this case, we're not looking for nodules because they don't form nodules. And you can't see this type of mycorrhiza, but you're supposed to see, just look at the root system and see how healthy it looks. And now, although it doesn't look like much here, but a subtle difference can mean a lot in terms of yield differences. Now, if you look, I think from here you can tell this is uninoculated and this is inoculated. Just look at this replicate and look at in the back there as well. Now you can sort of tell, there seems to be some difference here between the inoculated and the uninoculated. So that's one variety. And this is durum wheat, and this is another variety of durum wheat. And that's a third variety of durum wheat. So again, just comparing inoculated and uninoculated. Sometimes when they are too close, the plants are too close, you can't tell. But look at the ones close in the back there. Sometimes you see better when the plants are a bit further from you. Any questions? How are we doing for time? How are we doing for time? Yeah.
Running a little short, but not bad.
Okay. I'll just ask a final question here about some of these biological products we see on the market. Has anybody tried those? Some of these liquid products that you see on the internet, or do you know what I'm talking about? Has anybody tried them? The biological products that are supposed to work wonders for you in the soil. No? And I'm not talking about micronutrients, but yeah. Right. Yeah. Well, looks like yeah, you guys maybe are not quite familiar with those, but that's a good thing. The only thing I was going to say is whether they work or not, I don't know. See, they have all kinds of claims, and the best way to do is on your farm, if you want to try a product, just try it out first before investing in it. Have a patch with that inoculant in and a patch without that, and just see what the difference looks like before you invest big. Anything else? Okay, so I'll leave it there. How
about liquid inoculants? You never touched on those.
Oh, liquid inoculants. Well, so liquid inoculants, it depends. Are you talking liquid inoculants applied to the seed or to the soil?
Either.
Either way, yeah. The thing about these formulations is, under normal conditions, if everything is okay on the farm, usually formulation doesn't matter. Okay, your peat, your granular, your liquid, whether applied to the seed or the soil, they all work perfectly. But the difference comes when you have issues on the farm. Is your soil acid? Was it a dry year? Or was it a very wet year, too wet? So in those kind of conditions, research has shown that the granular inoculants tend to perform better in those conditions than these other formulations. But if everything is fine, the weather is fine, there shouldn't be much of an issue. Yeah.
Yeah. Hey Newton, I've got a question for you. which I kind of lost all of a sudden. Hey? Talked about the weather and it erased my brain.
Okay.
So you talked about the symbiotic relationship of inoculants and the plant, and that it does come at a cost to the plant. Now, I've also heard that, oh yeah, we should get nitrogen fixing wheat. They should genetically modify that. That would be awesome. What's your take on that? Is it really that awesome, or does it come at too much of a cost?
People have tried for a long, long time to have that kind of thing in wheat. See, the difference with the legumes is that nodule. That nodule is a very complicated organ. You know, it houses the rhizobium, but it also controls what goes in and out of that nodule. Wheat doesn't have that kind of structure, but people are trying to engineer it so that they can have some kind of structure similar to the nodule. But up to now, attempts haven't been successful. But people are still trying. So with this GMOs now, who knows? You know, there might be something coming soon. But up to this point, it's been difficult.
And I guess then the follow-up question is it worth it? Like, you know, it's always a trade-off, and it comes at a cost of the plant.
Yeah.
You know, like depending on the price of the crop, say the dry bean guys, they don't really rely on the nitrogen fixing capabilities because the fertilizer is worth it, worth the response essentially.
Yeah, that is true. But I think if we had such a system, it would help environmentally at least. So that we don't have to apply so much fertilizer. Yeah, I mean, like for legumes, for example, you know, we don't apply as much nitrogen fertilizer on legumes, so the environmental footprint or the carbon footprint or the whatever footprint is less. So if only just to protect our environment, it would be good to have nitrogen fixing wheat.
Okay. Any last questions for Newton? All right, join me in thanking him.